In this video, we're going to introduce a third method for solving quadratics. It's the quadratic formula, and we're not actually going to solve any problems in this video. It's just to let you know every single method, every single technique that you're given in math. No matter how complicated it looks, there's reasons behind it. And it's not your job in Algebra 1, I don't think, to understand all of these reasons, but I do think it's an important takeaway from the class to kind of, no matter what's thrown at you, you should always ask, so how did that work? Sometimes you're able to understand it at that time, and sometimes you're not, but you should always be curious about how something works. So here goes, introduce the third and final method. So here is a fact. There are two solutions to an equation that looks like this. We learned that because of the fundamental theorem of algebra. X squared, the highest exponent, tells you there's two answers. And here is a formula that you could use using the numbers that are in the equation to find what x is. X is equal to, it's a fraction, so brace yourself. And it's equal to the opposite of b, that middle coefficient, plus or minus, the square root has something to do with that squared. And okay. So you see something like that and you think, well, that's pretty far-fetched, maybe. Pretty challenging to come up with something like that. So what I'm going to do is I'm just going to show the steps that luckily mathematicians went through, and then really our work for this course is going to be able to use this thing. But again, I want you to see that everything that we do, there's reasons for it. So yeah, you might be over the what now. The why is we might need to do this because we can't always factor every quadratic, because the setup looks a lot like it's set up for the zero product principle. It would just be a matter of turning this into a principle. Into a factor. But when we can't factor a quadratic, that's where we're going to have to use the quadratic formula. So how did we get to that point? Well, here goes. So they start with the equation and they want to solve it. And inverse operations are usually a great thing to do, but we've seen that inverse operations are going to fail us somehow. But some pretty clever mathematicians worked on this. So what they did was they looked at this side over here and they thought, if I can't factor it right now, let me see what I can do to factor it. And they're not going to factor it in any certain way, like in any way whatsoever, because if it was factored equals zero is what we're going for, the zero product principle, then we're about to ruin it. So they've got a plan as they do this. So what they've done so far is they've subtracted c from both sides, and this left-hand side, what they've done is they've factored the a away from the x squared, because they can create a perfect square trinomial here, which is going to allow us to rewrite this with a squared. And that's going to give us access to the inverse operations. But in order to do that, they've factored a out of b, which is, pretty theoretical. So you got this fraction developing. And then to try to figure out what number right here is going to make this a perfect square trinomial, they had to do some analysis. So they looked at that and they said, well, I know that a perfect square trinomial looks like this, and this middle term, 2p, this coefficient for a perfect square right now the role is being played by b over a. So I guess if we want to figure out what p squared would be, the right number for a perfect square, we would have to play from this fact. So we would divide both sides by 2, and we would get this new fraction, and then to get what p squared is, we would square both sides so we could figure out what was there. Okay, so that feels like the number that if I put it here, believe it or not, is going to make this a perfect square trinomial, and it's going to make it factorable in a very special way. So we'll go ahead and we'll throw that in the parentheses, but if we do that, you've changed this side of the equation. So it's not like you can just throw that there because you need it there. You have to balance that on the other side. And the complication comes in because throwing something in the parentheses here, what is the actual effect to this side of the equation? It's an a times that much has been added to that side. So that's what's seen here, a times that much. Man, these people were clever. So now what they've done is they've made a perfect square trinomial here, and that's going to be factorable. So we will, and that's what they're doing, that's what we're noticing over here, it's going to be factorable. So we will factor it as x plus p squared, and according to our notes, p was b over 2a. So in our next line here, this has been replaced by x plus b over 2a squared. And this is just coming along for the ride. So why was this important? Well, because we can use square roots eventually. This a has to get divided out from both sides. So I'll divide it over here. For balance sake, I'll divide it over here. It's going to show up here, and it's going to have a nice convenient work there. So if I divide both sides by a, those cancel. And within this division right here, this a and that a will cancel, leaving me with no evidence of that, but the a did show up as division down here. So what happened in this move over here? Well, we are now going to try to square root this side. And before we do that, let's combine like terms. So that's going to take some fraction work, and they've done that here. And then we can, because we made a common denominator, we can add those together. A negative 4ac and a b squared have been rearranged. And then we can now we can get around to inverse operations. So we can square root both sides. And then I'll create this on this side, and we'll get plus or minus the square root of what we had earlier on this side. okay? And then now it's a matter of solving for x, because for as much as x was all over the place here, x is only in one spot now, so I think we just have to remove this term and maybe simplify this a little bit. So we will first remove that term, subtract b over 2a from both sides, and that just joins this term as a new term, and then we will notice the square root of a fraction is about square rooting the top and square rooting the bottom, and the bottom is really square rootable. So we get that. And our final answer, because we have the same common denominator once again, is this guy up here. So that is something only a mathematician could love. You guys might have liked that, but everyone's going to have to learn to appreciate this and to use this. So that's really where our focus will be moving forward.